All right.
Okay,
So,
join.
okay. So starting over. We're kind of introducing the elimination method, but before we actually do the method, I'm just going to show you that you can actually add and subtract equations. But you've got to make sure the variables are lined up correctly. So here I've got the x's are lined up, the y's are lined up, the equal signs are lined up. That's actually important too, and then the constants. If you have everything lined up like this, then you can, just like you would, like how you would add, regular numbers the old school way, you just put the equation bar and you'd add them like this. And then you add the terms together. So 3x plus 7x is 10x. We can do that because they're like terms. -4, right? Think of that as a -4. Plus 9 is 5. So it's a positive 5.
What's that, Chase?
Y. Okay. And then this last one is 5 plus -11. So that's -6. So there you go. And now we have this, we've taken these two equations and made them into one equation, and that's a legal move to do in algebra. You can do that. What questions do you have on that?
Nothing.
Okay, all right. So let's, so I'm gonna erase that, or do you guys want to write that down still?
I'm good.
Okay, all right, cool. So here, I'll give you a different situation. If I wanted to take, let's say, y equals 7x plus 3, and I wanted to add that to 2x minus 3y equals 10, I couldn't do that just yet because remember how I said they had to be lined up. So we're going to have to rearrange one of these equations to be in the same form as the other one. It doesn't matter which one you do, but you just have to make sure one of them gets changed. So again, if you look, I kind of made this one in slope-intercept form. This one's kind of in the standard form. How about I'm going to convert the top one into standard form. So see how if I can get this x in front, then it'd be in the same form as this other one. So I can do that by if I subtracted 7x from both sides. Okay, so then these would cancel, and this would become, let's see, I'll actually, see, I got space this way. This would then become -7x. I'll write the -7x first. Then the positive y, so plus y equals the 3. Does that make sense how I went from here to here?
Yeah.
Yeah.
Okay. So now the nice thing is now I'm just going to rewrite this one directly underneath it so that they're lined up. So that's going to be 2x minus 3y equals 10. Okay. And now this time, just because I'm going to show you how you can then subtract equations. So last time I showed you adding, subtracting is very similar. Subtracting, again, it has to only happen when they're lined up nicely like this. So then it's just a little more, subtracting is a little harder than adding, but it's the same thing. So whatever -7 minus 2 is, goes here. That's a -9. It would probably be useful to write in the coefficient on this y, which is a 1. So 1 minus a -3. So be careful there. 1 minus a negative is going to be like adding. So that's 1 plus 3 is 4. And you can always use a calculator for that too. And then 3 minus 10 is -7. Okay. Does the green not show up very good?
Not really.
Not really. Okay. So here I'll just go over again. I'll stop using green then. Is this showing up okay? Better with?
Yeah.
Yeah.
Okay. All right. Good. So some things there. You need to have them lined up. the right way, and you can either add or subtract equations. This is something we can do. Now that's not actually the method yet. We have to actually use the method to solve a system. So today I was only going to show you the first level of using this, where you're going to get certain systems of equations so that when you add them or subtract them, one of the variables cancels out or eliminates. That's why we call it the elimination method. So here, I'll show you an example of that. Okay. Now, I'm just making up some equations. So forewarning that we might get decimal or fraction answers, okay? That's typically, that won't happen on IXL. They're all going to be integer answers, so like whole numbers, positive or negative answers. Does that make sense?
Yeah.
Mm-hmm.
Okay, cool. All right, so let's see here. Let's go 5x plus 4y equals 28, let's say. And then we'll go negative 5x minus 7y equals negative 34. Again, this more than likely will have decimal answers since I'm just kind of making them up. But notice I already have them lined up. And so that we can either add or subtract the equations. Now, the reason, if you look closely, the x coefficients are very similar. Do you see how this one's 5 and then this one's negative 5, right?
Mm.
So if we were to add those equations, what would we get for the coefficient on the x?
0.
0, yeah. So that's when we can, when they make 0, that's when we call it elimination, right? It's eliminating. So we could add or subtract, but since we know if we add, those are going to cancel. That's what we're going to do. We're going to choose to add. So I'm going to take these two and add them, because now I know 5 plus negative 5 is 0 or 0x, or they just cancel out. Okay. And then I would go down to the next one. 4 plus negative 7, that does make a number. That's a negative 3. And then 28 plus negative 34 is what? Negative 6. Hey, actually, this is going to work out nicely. Imagine that. Because now what we can do is we can solve for y. What could we do from here to solve to get y by itself?
Divide by negative 3.
3. Yeah, 3.
Yep. Yep, divide by negative 3. Yeah. Divide by negative 3. Those cancel. And then y is equal to positive 2. All right. So that's part of the answer. We're not done yet. Remember, when you do a system of equations, you have to get the x and the y. So I could like say, okay, I know my answer. I know part of my answer. I know that the y value is 2. I just need to figure out what the x value is still. And the way we find the x value is just like we did with substitution. You can take this y value of 2 and substitute it back in for one of the y's of the original equations. So, yep, green doesn't work. I gotta remember that. Let's see, we'll go red, I guess. So y value of 2 can be plugged in for this y up here or this y here. You guys have a preference to which one we plug it into?
No.
Okay. I don't know. The bottom one's got some negatives in it, so maybe the top one. How about? So what would that look like? We have space over here. Okay. Yep. So that would be 5x still plus 4. Now instead of y, I'm going to replace it with 2. I'll use a different color for that. And then equals 28. And now we can just solve for x. So multiplying, that's 8. 5x plus 8 equals 28. Subtract 8. Or does that make sense to subtract 8?
Mhm.
Okay. All right. That cancels. Then that's 5x comes down equals 20. And then divide by 5. And then x is equal to 4. So now that's the other part of our final answer. We can plug 4 in that spot. So 4, 2 would be the answer. So we'll eventually learn how to do this when the system of equations is not set up nicely. Like, it's very possible we could have gotten a system of equations where the numbers were not going to cancel out this easily. So tomorrow I was going to focus on that side of it, just kind of go slowly through this. Another thing, though, I could show you another example where instead of adding the equations, we subtract the equations. Start over this way. So let's say we have 3x minus 6y equals 21. And then let's say we have 4x minus 6y equals. I think 19. This one will work out nicely, but we might get fraction or decimal answers. Okay, so now this one's you can see maybe, well, which coefficient stands out a little bit in this situation?
The y or the -6x or y.
Yeah, the -6y is because they're the same, right? Now this one throws people off sometimes because they're like, when I ask sometimes, do you add -6 plus -6 to get 0, or do you subtract -6 minus -6 to get 0? And well, the answer is whenever the exact same number, the way you cancel them is with subtraction. And you can double check that on a calculator or something, or if off to the side here, -6 minus -6. Well, you could rewrite the minus negative into adding, and maybe you can see now that that's 0. Does that make sense?
What are you doing?
My Chromebook here.
Okay. All right. Anyway, so to solve this one, well, and again, the x's, the y's, the equal signs, and the constants, they're all lined up, so that's good. So to solve this one, we'll subtract. So write our equation bar, subtract. Okay. So 3 minus 4 is, what's 3 minus 4?
-1.
-1. So that's -1x. Now I just explained this over here. What's going to happen with -6 minus -6?
They're gonna cancel.
Going to cancel. So those eliminate, and then equals 21 minus 19 is what's that?
Okay. 3.
Well, just off by 1. It'd be 2. Does that make sense?
Oh, yeah. Sorry.
No, it's fine. All right, cool. So now we've got this equation that's pretty simple. What can we do to solve that equation?
Divide by -1.
Yeah, divide by -1. Good. So those cancel, and then that's going to be x equals negative.
What? This is a class meeting. Well, that.
All right, so we've got x equals -2. Again, so that's like half of the answer. So maybe I'll set it up. I know that -2 is my x coordinate. To find the y coordinate, I can plug this -2 back into either the top equation or the bottom equation. It really does not matter which, unless you think one looks easier.
No.
Any preferences?
There's security
Uh,
in my house.
How about the bottom one, I guess, unless somebody objects. So I'll
mm,
plug it in for that X right there. So we'll do that over here. So that'll be 4, but instead of X, that's -2,
-2.
and then -6Y equals 19. And now we can solve for Y. So multiply first, so that's -8. 4 times -2. Okay. We're trying to solve for Y, so we want to cancel that -8. How would we do that?
Add 8.
Add 8 to both sides and equal sign. I guess we could be making a separation line here. Anyway, that cancels. That's still a -6. So -6Y equals that's 27. Okay, so we are going to get a fraction answer here because when we divide by -6, 27 does not divide by -6 nicely.
Yeah.
If you made it into a decimal, it'd be some repeating number. So what I would like to do is let's just reduce that fraction. What can you divide both 27 and 6 by?
Uh, 3 or yeah, 3.
You can divide them both by 3, and that'd be 9 on top. Well, it's negative because of the negative, so I'm going to -9 over 6 divided by 3 is 2. You could write it as -9 halves, or that actually doesn't work out nicely as a decimal. It's not a repeating decimal is what I mean. It's -9 over 2 is -4.5. So now again, on IXL, I don't think you're going to get answers like that, but it's fine. So I'll write it as the fraction, -9 halves in my final answer. Okay. So that's the level 1, I would say, for elimination method.